Welcome to NPS online class. Today we will read chapter 16 in subject science. So chapter name is light. There are following topic which we have to cover in this chapter. Our first topic is reflection, regular and irregular reflection. Second topic, laws of reflection. Third, image formed by a plane mirror. And our last topic is multiple image. So get started. The world is largely known through senses: the sense of sound, sense of taste, sense of touch, etc. But the most important is the sense of sight. Through this we see the wonderful colors of flowers, fruit, animals, plant, blood, butterfly, rainbow in the sky, so many other things. What makes things visible? You may say that I see the object around us, but you cannot see any object in the dark. It means the eye alone cannot be see any object. It is only when the light from an object enter our eye that we see the object. The light may have been emitted by the object, for example, luminous object, and luminous object is sun, fire, etc., or may have been reflected by its non-luminous object, that is moon or any other object. Next point, reflection of what is reflection of light? When of light hit a mirror or any polished surface, it changed its direction and it bounced back into the same medium. Reflection means when a ray of light hit the mirror or any polished surface, it can change their direction. It turn back into the same medium, either its medium in air, water, etc. So this phenomena is called reflection of light. The amount of light that is reflected by an object depends upon the material and nature of the surface on which lights fall. An object which absorbs some of light that form on its and reacts the remains light is called opaque object. For example, stone, any material, wood, etc. Next, an object that allow all the lights to pass through it and reflected little light is called transparent object. For example, glass, water, air, thin polythene sheets, etc. Next, in object that allows some light to pass and some get reflected back, it is called translucent object. For example, milky glass, thin polythene sheet, butter paper, etc. A smooth and highly polished surface are the best reflector because they reflect amongst all the light that fall on it. For example, mirror, stainless steel, etc. So our next point is type of reflection. So there are two type of reflection. First, regular, and second, irregular reflection. So here we see first type first. Firstly, we see here first type of reflection. Why it is that all the surface around us do not act like mirror. You know that light bounces off all kind of surfaces, but you can see image of object only from a high polished surface like mirror. This is because if a beam of light fall it, the entire beams is reflected in one direction. So this reflection is called regular reflection. However, if the surface of an object is rough as well as you see most of the object around us are not so smooth, then the beam of light get reflected in many different direction. This is called regular, irregular or diffusion reflection. So irregular reflection is also known as diffusion reflection. In next page, see the differences of types of reflection. First ray diagram show regular reflection and second ray diagram show irregular reflection. Do you know that it is because of irregular reflection that we can see object from every direction? In irregular reflection, we can see any object in every direction, even if sunlight does not directly fall on them. Next, our third topic is law of reflection. Draw a line. First, we considered here one activity. Activity first, to study the first law of reflection. Fix a sheet of white paper on a drawing board or a table with the help of thumb pin. Take a comb, as you also see in your figure, activity figure. So take a comb and close all the openings with a strip of black paper, except one in the middle. Hold the comb perpendicular side to the sheet paper. Darken the room. Keep the plane mirror vertically in the path of light. Throw light from a touch through the opening of the comb from one side as shown in figure. With slight adjustment of the torch and the comb, you can see a ray of light along the paper on the other side of comb. After striking the mirror, the ray of the light is reflected in another direction. So the light falling on the mirror is called the incident ray. And on the other hand, the ray that comes back from the mirror is called the reflected ray. If you rotate the mirror, this reflected ray also rotate. So this incident ray and reflected ray are equal angles are equal to each other. So hence it is called first law of reflection. Draw a line showing the position of the plane mirror, an incident ray and the reflected ray on the paper. Mark the position of the mirror dash with a straight line. Mark the path of the incident ray AO and the reflected ray OB. Measure the angle that the ray and the reflected ray make with the mirror angle MOA and angle M-OB. You will find that the angle are equal. As you also see in figure 16.2, drawing the angle. First angle AOB, so incident ray, and second OB, so MOB, so reflected ray, and another angle MOA, so incident ray, and M dash, so plane mirror. So this is a figure of drawing of angles. And another figure, so angle of incidence is equal to angle of reflection, that is I is equal to angle angle R. Now draw a line OX, make an angle of 90 degree to the line MM dash representing the mirror where the incident ray strike the mirror. This line is known as normal to the reflected surface at a point that is 0. The angle between the normal and incident ray, angle AOX, is called angle of incidence, that is angle I. And on other hand, the angle between the normal and the reflected ray, angle BOX, is called angle of reflection, that is angle small r. Measure these angles. You will see that angle AOX and angle BOX are equal. Since therefore angle small I, called angle of incidence, is equal to angle small r, called angle of reflection, are equal to each other. Angle of incident equal to angle of reflection. Repeat the activity several times by changing the angle of incident and enter the data in table given. In next page, so here given a one activity table, we change the angle of reflection and incident and enter here, and lastly we see angle I is equal to angle R. If the experiment is carried out carefully, it is seen that angle of incident is equal to angle of reflection that is known as first law of reflection. Activity second, to study the second law of reflection. Perform activity first again. This time use a sheet of shift white paper or a chart paper and extended it beyond the edge of the table. Cut the projection portion of the sheet in the middle. Look at the reflected ray. Make sure that reflected ray extended to the projection portion of the paper. Bend that part of the projected portion on which reflected ray falls. Does the reflected ray now reach the edge of the paper? Bring the paper back to the original position. Can you see the reflected ray again? When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incident, and the reflected ray are all in this plane. When you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. That's why you cannot see the reflected ray. It indicates the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. So this is called second law of reflection. Law of reflection or second law of reflection. Image formed by a mirror. The two law of reflection started above remains the same regardless of the shape of the mirror used. However, the characteristic of the mirror form depending upon the type of mirror. In this part, we will study the formation of image formed by a plane mirror and its characteristic. So let me consider activity 3. Activity so to locate an image formed by a plane mirror. Keep a plane mirror vertically side along the line mm dash on a sheet of white paper fixed on a drawing board. Place a pin point O, means object, as you also seen in your figure of activity 3rd. Mark on object O which right hand side and left hand side called incident ray. Incident ray fall on this paper sheet whose image we want to locate. Draw two incident ray OA and OB. Place two pin C and D on these rays as shown in the given figure. Now fix E and F pin such that E, F and the image of O and C appear in a straight line. Again fix G and H pin such that G and H and the image of O and D can also appear in a straight line, as you also see in your activity 3 figure. Locating the image formed by a plane. In next page, image get formed. Remove the mirror and pin. Extended the two ray FE and GH, that is called reflected ray, backward such that they meet at a point I, that is called I, capital I is called image. Image line across the plane mirror M and M dash. You will notice